Now let's talk about acceleration. What is acceleration? Now you can counter acceleration when drive a car. Another way to think about it is imagine two vehicles. Let's say a truck. I will draw you a truck and that more strategic person, but instead of this, and let's say we have a sport car. Which of these two vehicles have, let's say, a greater acceleration? Is it the truck or the sport car? So what is acceleration? Acceleration tells you how fast the speed is changing, or more technically, how fast the velocity is changing. So the truck can probably grow from 0 to 60 miles in, let's say, maybe 30 seconds. A sport car can go from 0 to 60 in a short period of time, let's say in 5 seconds. So because the sport car can get to higher speed, which is a certain speed faster than the truck, it has a greater acceleration. And so acceleration tells you how fast the velocity is changing. Acceleration is defined as the change in velocity divided by the change in time. Which sometimes you can put t. So you can write this way. Wait. So this, you see the triangle, this means the change. So acceleration can be defined as final velocity minus initial velocity and divided by time. So to calculate the acceleration of a truck, notice that the changing velocity is 60. 60 minus 0 is 60, and divided by 30, 60 divided by 30 is 2. So the acceleration of this truck is 2 miles per hour per second, because we are dividing the speed as mile per hour by second, so it's 2 miles per hour per second. Now the acceleration of the sport car is 60 miles per hour and divided by 5 seconds. 60 divided by 5 is 12, so it's 12 miles per hour per second. As you can see, the acceleration of the sport car is much greater than the truck. The truck is gonna take a long time to go from 0 to 60, but the sport car will get there a lot faster because it has a greater acceleration. And so that's the basic idea behind acceleration. It tells you how fast the velocity is changing. I will draw a table. Let's say if an object is moving with initial speed of maybe 12 meters per second. So this tells you the initial speed of the velocity. So since we have arrow is going east, this now is become description of velocity if I put direction with it. Now let's say we have point. This object of vehicle begins to accelerate at the rate of 4 meters per second square. So this is 4 meters per second per second. So what's that mean? So if you make a table, t for time, v for velocity, let's say final velocity at a certain time, when t is equal to 0, the initial velocity is 12. So when t is 1, the final velocity is changed. The acceleration tells us how fast the velocity is changing. So because the acceleration is positive 4, that means that the velocity is increasing by 4 meters per second every second. So every time acceleration is positive, the velocity is increased. But every time the acceleration is negative, the velocity is decreased. So 1 second later, the velocity would be 16. 2 seconds later, the velocity is 20. The 3 seconds later is 24. 4 seconds later, it's 28. And so on. And every second, the velocity will increase by 4 meters per second because acceleration is 4 meters per second per second. Now, the formula that you need to know is initial velocity plus at. Now let's say we have another object that is moving in eastward direction at a speed of, let's say, 24 meters per second. But this time, let's say the acceleration is negative 6 meters per second squared. What's going on here? Is this object is speeding up or slowing down? Whenever the acceleration and velocity, whenever they have an opposite sign, the object is slowing down. Whenever they have the same sign, it's speeding up. And let's example, the acceleration was positive 4 and the velocity had positive values. So it started with positive 12. And so because the velocity and acceleration has the same sign, the object was speeding up. So the object would be speeding up, or the speed will increase if the acceleration and the velocity has the same sign, if they both positive or both negative. The object would be slowing down if the velocity and the acceleration has the opposite sign, or either positive negative or negative and positive. In this example that I'm going to show that. So this time I'm going to make a table with t for time, velocity, and I'll be using sp for speed. So at t is equal to 0, the velocity is positive 24. And remember that speed is absolute value of velocity. So the speed is positive 24. Now 1 second later, we'll have the new velocity. The acceleration is negative 6. And recall that if acceleration is negative, the velocity would decrease. So it's going to be 18. So 24 minus 6 is 18. 2 seconds later, it will be 12. 3 seconds later, it's going to be 6. 4 seconds later, it's 0. 5 seconds later, it's going to be minus negative 6. And then negative 12 and minus 18 and so on. But speed is always positive. Positive 18, positive 12, positive 6, 0, positive 6, positive 12, positive 18. Now let's focus on the first half. In the first 4 seconds, the object is slowing down. If you look at the speed is decreased from 24 to 0. So what's happening is that the object is moving, but over time, it's moving slower, slower, and slower. And so at 4 seconds, it's not moving, however, it's changed direction. Notice the velocity, it's going from positive to negative, which means that it's changing from eastward direction to the westward direction. It's begin to move faster toward the direction. So you can see it's speeding up because the speed is increasing after 4 seconds. Now remember what we said before. If acceleration and velocity, if they share the same sign, then the object would speeding up. That is the same positive or negative. But if they had opposite sign, then the object is slowing down. So during the first 4 seconds, the velocity is positive and the acceleration is always negative. Therefore, because their sign is opposite, it's slowing down. The speed is decreasing from 24 to 0. Now, during the second part of in this problem, that is after 4 seconds, the velocity is negative and acceleration is negative. So because they share the same sign, the object speeding up. As you can see, the speed is increased from 0 to positive 6, positive 12, and positive 18 3 seconds. So make sure you understand the concept. If acceleration and velocity share the same sign, the object is speeding up. If they have the opposite sign, it's slowing down. Now let's move in our gravitational acceleration. In this physics, you see that G and is equal to negative 9.8 meter per second square. So this is the gravitational acceleration of planet Earth, and it varies for different planet and other very large object. So the gravitational acceleration of the moon, for example, is negative 1.6 meter per second square. It's a lot less. One reason the moon has less mass than the Earth. And so you will awake a lot less in the moon. You'll feel lighter on the moon as you can jump higher on the moon. But let's focus on the gravitational acceleration for Earth, negative 9.8. What does that mean? On the last example, we saw what a negative acceleration can do to velocity. And so the fact that this gravitational acceleration is negative means that it will always decrease the velocity. Now, the gravitational acceleration of the Earth is act in the y direction and not in the x direction. As we talk about velocity, the velocity is a vector. It can has an x component and can has a y component. The actual velocity is basically it is the hypotenuse of the coordinate. Vx is the component of the velocity vector. Vy is the vertical component. The gravitational acceleration doesn't affect the Vx, it affects the Vy. So technically you can define as Vy is a vertical gravitational acceleration. It doesn't affect the horizontal velocity, it affects the vertical velocity. So make sure you understand that. Now let's see, we have an example. Let's say a person understands sometimes gy can be explained as ay, so it's basically the same. It's negative 9.8. So let's back to our sample. It has to be we have a person who is standing at the top of the cliff next to the ocean, and this person has a ball in his hand, and he released the ball from that. So he doesn't throw down or throw down, but he simply let go of the ball. We know that's what can happen is the gravity will make the ball gonna fall. Now we have the vertical velocity. Over time, it's become positive or negative. We know that velocity is the speed of direction, and by now, the ball is going to be moving in the negative y direction. So this is the positive x, this is negative x, positive y, and negative y. It's going down in negative y direction. So Vy become negative. If we make a table with t and Vy at t equals 0, the initial vertical velocity would be 0 because the ball was released from the rest. Now the acceleration, or also called gravity acceleration, is negative 9.8 because in negative, the vertical velocity would decrease. So every second, it's going to decrease by 9.8. So 2 seconds later, it's going to be 19.6. 3 seconds later, it's going to be negative 29.4 meters per second. Now the speed is always going to be positive. So if you are asked, what is the speed of the ball? let's say 3 seconds later, it's going to be positive 29.4 meters per second. But if the test question asks you, let's say, the velocity of the ball 3 seconds later, you should say it's negative 29.4 meters per second, because it's going into the negative y direction. And so hopefully this number makes more sense. So the gravitational acceleration tells you how fast the vertical velocity is changing every second. So on the moon, where its g is negative 1.6, if you were to throw a ball, the vertical velocity would decrease by 1.6 meters per second every second. So let's say we have a similar situation. We have the same person with the ball in his hand, and this time he throw it in the upward direction with, let's say, the speed of 29.4 meters per second. What can you tell me about the vertical velocity and its value every second? Let's say this person is standing on the cliff and on the earth, where g is negative 9.8 meters per second square. So even though I know that velocity is positive because g is negative, the vertical velocity is decreased. So as the ball goes up, it's slowing down because the velocity is positive and the acceleration is negative. Because they're opposite in sign, the ball is slowing down. Eventually, the ball will reach the maximum height, and then it's going to change direction and become to fall down. So if you make a table between t and the Vy, we're going to get the value. So when the t is equals to 0, that is initially the vertical velocity is positive 29.4. When the t is 1, the acceleration tells us how fast or how much the velocity is changing every second. So when 1 second later, it's going to decrease by 9.8. So 29.8.4 minus 9.8 would give us 19.6. So 1 second later, it's going to be positive 19.6. 2 seconds later, it will decrease again by 9.8. So it's going to be positive 9.8. 3 seconds later, it's going to be 0. So when vertical velocity is at 0, that means that the ball is not going up anymore. It's going down yet. It has reached its maximum height. So let's take 3 seconds to get the maximum height. Let's call this the position A, position B, position C. So when t is 0, it at position A. When t is 3, it at position B. 4 seconds later, it's going to be negative 9.8. 5 seconds later, negative 19.6. 6 seconds later, it's going to be negative 29.4, and so on. And so once you get to the position B, when it passes that position, the velocity would be negative because it now is going in the down direction or negative y direction. So that's the mathematical profile for this situation. So now you understand what's happening to the velocity values as time progresses. So anytime acceleration is negative, the velocity is decreased. As you can see, it starts with positive value and end up in negative value.